Hello friend, this is Amit. Today I am going to solve this question which is gate previous year problem. Okay, so in this problem first we have to understand what the problem says, then we proceed. So the problem basically says that we have a vector A, okay, which is direction outward, radially outward, okay, radially outward from the origin, radially outward from the origin, and here the vector A expression is given as k r n minus 1, where r is given as a x square y square z square, which means that we are dealing in a coordinate, okay, coordinate dimensions. Okay, so we have to deal in a x y z direction, and here we are having a spherical body. Okay, so here to solve this equation we can use many different methods, okay, to get the solution, but I want to use EMT EMT equation, uh, which we can recall from spherical coordinate dimensions. Okay, so what we get from spherical coordinate dimension is that that in a spherical coordinate dimension in EMT, what we have three dimension r, theta and phi. Okay, so here I try to give you the natural view of r, theta and phi. Here this one represent that r, which changes from origin to the radius, complete radius, and theta is changes vertically. Okay, and phi is changes horizontally. Okay, if you take any object, any point in this position, okay, so in this position, if we can calculate theta as in this direction. Okay, so theta make angle with this x as theta. Okay, with x direction. Okay, so basically we can calculate theta, phi and r from spherical dimensions. Okay, now solve this problem. So from EMT we get the spherical dimension equation as below: r square sine theta del r square sine theta ar, which is the radially component of vector r theta. Okay, dr sine theta a theta, which is the theta component of the vector. Okay, d theta dr a phi. A phi is the phi component of the vector. Okay, and d phi by d phi. So here we are having the equation of vector A is k r n minus 1 r. Okay, why I written r here? Because we are dealing with r only. Okay, in the vector there is no theta and phi component, so we have only radial component with us, so I represent it here as a radial vector. Okay, so now we have to calculate unit direction. Okay, radial unit direction, so it can be represented as r cap r vector mod r. Okay, this is the standard equation which we use in vector coordinate. Okay, this is the mod r, and you can directly written as r. So now this equations become ar k n minus 1 r. Okay, r mod, yeah, r you can directly take it as r. So now the thing is that now this vectors, we can represent this vector with only radial component. okay, with the radial component, because we have already solved, uh, we have already seen that this vector have only a radial component and nothing else. So we can represent as k r n minus 1 r. Okay, so this is the radial component of this equation. Okay, now see it. This is the given vector and this is the radial vector of this is the given vector, and this one come from this the radial component of this vector. Okay, understand? Now from this equation, as uh, we are given in the problem that gradient of a gradient of vector is given as 0, so put it as a 0. Okay, now take it down here. Okay, if we take it down here, what what we have only this equation. Okay, this equation we have with us, so I'm going to put it here. Okay, now the thing is that we have to deal with this equation only, and as the problem says, divergence of curl is 0. Okay, close it now, parenthesis. Okay, and now we are having a radial direction of the given vector, so solve it. So what's come out is you can written is as also as like this kr this. Okay, as this comes in, this make plus 1 and cut by this, so yeah, become like this. Okay, now take it down here. Divergence of vector a, which is come as 1 by r square from here, as there is no theta component, so theta and theta gets cancel out. Okay, now we are having only r component inside. Okay, now written here r square. Now take down the ar here, which come as n r n. Okay, sorry for this mess up. Okay, now solve it. After taking derivative of this, k comes out. Okay, and r remain in the inside, so it's become k r n minus 2 by dr. Okay, and here it is k square. Okay, and as we have seen before, that's it's a 0. So when we take down the derivative, it's as come as k and come here as a plus 2, sorry, and come here as a plus 2, and r n minus 1. Okay, r come as a r minus 1, and we are having a r squared. Okay, so put it here, r square equal to 0. Now get it here, so this one's come here. Okay, this goes here. Now it's become n plus 2 r n minus 1 k. Okay, now if we take the whole equation, so what it's become like this, as this shows that k r n minus 1 from the previous equation, and it's n minus n plus 2. So this equations never be 0, because this is the our given vector. Okay, so we have to put this equation into 0 equal to 0. So take down this equation as 0 and plus 2 equal to 0. So this equation comes out. Okay, I hope I helped you to get the concept of this problem. Now give a review. We are having a vector a which is radially outward from the origin, and having vector a as given now, and this is the r equation which we have, r square x square, okay, x square y square z square, which makes no sense. Okay, we don't even need this equation. The procedure we use below. Now take down the spherical coordinate from electromagnetic theory and keep follow the equations, and we get the solution as n minus 2. Okay, thank you for being with me.